We're going to talk about matrix multiplication in this video. And the first thing to know about matrix multiplication is that it's not always possible to multiply two matrices. Okay, so let's suppose we have a matrix A and a matrix B. And let's say that A is an M by N matrix. Okay, that's the size, M rows and N columns. And let's suppose that B is an N by P matrix. Okay, then we can multiply A times B. Okay, and in fact, A times B in this case would be an M by P matrix. Okay, now the thing to notice is that the N here, I chose the same letter N for the number of columns of A and the number of rows of B. Those have to be equal. Okay, these have to be equal in order to be able to define A times B. Okay, and notice A times B ends up being an M by P matrix. Okay, if these two numbers are different, then you cannot multiply the two matrices. Okay, that's different than multiplying numbers. You can always multiply two numbers together, but you can't always multiply two matrices together. Okay, so let's look at some examples. Oh, before we do the examples, read this note. We can only define the product, A times B, of matrices A and B if the number of columns of A is equal to the number of rows of B. Okay, let's look at some examples. Determine whether the matrix multiplication is possible. If it is possible, state the size of the product. Now notice this first matrix is a 4 by 2 matrix. Okay, and it's not 2 by 4, it's 4 by 2. We look down 4, right? We have 4 rows and we have 2 columns. Okay, and this is a 3 by 4 matrix. Okay, so can we define the product? Well, notice, is this number equal to this number? And the answer is no, right? These are not equal to each other, and so it is not possible to multiply these two matrices. Okay, think of the first matrix as A and the second matrix as B. It's not possible to multiply them. Okay, let's look in part B. Notice that we have a 3 by 2 matrix and a 2 by 4 matrix. Okay, is it possible to multiply these? Well, yeah, the 2 here is equal to the 2 there, so it is possible. And in fact, what will be the size of the product? Well, it will be a 3 by 4 matrix. Okay, so you could maybe even write in, what the matrix is going to look like. It's going to be 3 by 4. Okay, now we'll talk about how do you multiply these two matrices in just a second, but for right now, let's check to see, is matrix multiplication possible. Okay, this is a 2 by 3 matrix and this is a 3 by 2 matrix. Can we multiply these matrices? Well, yes. Notice that this is equal to this, right? The number of columns of the first matrix is equal to the number of rows of the second matrix. And what will be the size of the product? Well, it will be a 2 by 2 matrix, right? 2 by 2. Okay, so we can even write in, okay, let's draw something that looks like it'll be about a 2 by 2 matrix. Okay, and just two more examples here. Part D, notice that this is a 3 by 3 matrix. It's called a square matrix, right? It's 3 by 3. And this is a 2 by 3 matrix. And notice that this 3 is not equal to this 2. Okay, these are not equal, so it is not possible to multiply these two matrices. Okay, and finally, notice the last example. We have a 3 by 3 and a 3 by 3. Okay, we have two square matrices that have the same size. If you have two square matrices that have the same size, if they're both 3 by 3 or 4 by 4, then yeah, it will be possible to multiply the matrices. And in fact, the product is going to also be a square matrix, okay, of that same size. It will be a 3 by 3 matrix. Okay, so here's the question. How do you actually define matrix multiplication? How do we multiply two matrices? So let's look at part C. How do we multiply these matrices? Okay, well, the key is to do this. The key is that you take the first row of the first matrix and the first column of the second matrix, and we multiply these together. Okay, so what do I mean by multiplying a row by a column? Well, what we do is we do 6 times 3 plus 7 times 0 plus 2 times 5. Okay, that's how you multiply a row times a column. Now notice these needed to have the same number of entries here as we had entries here, right? And that's why this 3 had to equal this 3. Okay, so let's do it. 6 times 3 is 18, plus 7 times 0 is 0, plus 2 times 5 is 10, so we have 18 plus 0 plus 10, that would be 28, and that's the number that we're going to put up in the first row and the first column, right? This is row 1, column 1, because we did row 1 times column 1. Okay, the next thing you do, if you want to find the entry here, is we do this row, 672, by the second column. Okay, so this is row 1, column 2 will be this entry. So we're looking at row 1, column 2. 6 times 2 is 12, plus 7 times 4 is 28, plus 2 times 1 is 2, so we have 12 plus 28 plus 2. Well, 12 plus 28 is 40, plus 2 is 42. Okay, now for the bottom row here, we're going to take the second row and first multiply it by the first column. Okay, so 0 times 3, that's 0. Negative 3 times 0, that's 0. 10 times 5, that's 50. So 0 plus 50 would be 50. Okay, and finally, to find the entry in the second row, the second column, we look at the second row here and the second column here. We do 0 times 2 plus negative 3 times 4 plus 10 times 1. So 0 times 2 is 0. Negative 3 times 4 is negative 12. And 10 times 1 is 10. So we have 0 plus negative 12 plus 10, that would be negative 2. Okay, so here's our 2 by 2 matrix that is the result. Okay, we can do the same thing here. I'm not going to do this all out here, but here, if we want to find the entry in the first row in the first column, we will take the first row and multiply it by the first column. Okay, now this time we just have 2 entries though, right? We have this 2 that we circle in red. So we do 2 times 4 plus 5 times 7, so that'd be 8 plus 35, that's 43. Okay, then to find the next one here, we would do 2 times 3 is 6, 5 times 2 is 10, so we get 16. Okay, then 2 times 8 plus 5 times 0, that'd be 16 plus 0, that's also 16. And finally, 2 times 5 is 10, and 5 times minus 3 is minus 15, so we get minus 5. Okay, and then we start again with 3 minus 1. We do 3 minus 1 times each of these 4 columns, and we would put those entries here, 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 and here. Okay, and finally we would multiply this times each of those 4 entries, or four columns, and we put the entries there. Okay, so you're going to get a 3 by 4 matrix as a result. Okay, so let's do one more. Now notice this matrix down here, this second matrix here, is a special matrix. It's called the identity matrix. Okay, identity matrix. Okay, the identity matrix, if you have a square matrix, it will be called the identity if along this main diagonal here, your entries are 1, and everywhere else your entries are 0. And you'll see why this is the identity matrix. Okay, let's multiply these together. So notice if we take this first row by this first column, what do we get? Well, 4 times 1 plus 7 times 0 plus 5 times 0. Well, these zeros mean that when we multiply by these numbers, they're going to go away. So it's really just 4 times 1. We get 4. Okay, now let's multiply this row by the second column. So we'll get this entry. 4 times 0 plus 7 times 1 plus 5 times 0, that's 7. Okay, then finally, the last one, 4 times 0 plus 7 times 0 plus 5 times 1, that's 5. Okay, now let's go the next row. Okay, 5 times 1 plus 23 times 0 plus minus 6 times 0. Well, that would be 5. Okay, then we'll do this times this. 5 times 0 plus 23 times 1 plus minus 6 times 0. That's 23. And finally, for this last entry in this row, we'll get 5 times 0 plus 23 times 0 plus minus 6 times 1. That's minus 6. Now notice, we're really getting the same matrix back that we had originally. And if you continue this on, your entries are going to be minus 3, 2, and 10. So the reason that this is called the identity matrix is because if you multiply any matrix, any 3 by 3 matrix by this 3 by 3 identity matrix, you're going to end up with the original matrix. Okay, so that's called the identity. It's kind of like 1. In fact, sometimes we use the letter I for the identity matrix. But you can think of it as 1 because if you take like a number 5 times 1, you get 5, right? Or 7 times 1, you get 7. So 1 as a number is sometimes considered the identity or the multiplicative identity. When we're talking about matrices, the multiplicative identity, we use the capital letter I, but it's the matrix with 1s along the diagonal and 0s everywhere else. If we were talking about a 2 by 2 matrix, the multiplicative identity would be this. Okay, or a 4 by 4 matrix, the multiplicative identity would be this. 0s everywhere else, but 1s along the diagonal. Okay, so that's how you multiply matrices.